Hello everyone, and welcome to a quick little video on tinkering with quadratics. So I've just written down a random quadratic function f of x here, and I just want to find out some stuff about it. So I know things about, let's call it g of x, the base function x squared, and I know it's like something, looks like this, got this shape. And so I know that any function with the same highest power, so we have power of 2 here, is of this shape. So what I'm going to do is I'm going to just kind of explore some of the things I can find out about this function just because I know its shape. So one thing I could try to find is this point right there. Okay, so where's the vertex? And so we learned a process called completing the square to do that. You learned that in grade 10. But it's easy to forget because it's lots of steps. So I'm going to try to explain a new way of thinking about this that might help. So what we're going to do is we'll just write down our function. So f of x equals 2x squared minus 12x minus 14. And the first thing we're going to do is we're going to try to get this in our vertex form. So you're used to seeing this from grade 9 or grade 10. It would look like this: x minus h all squared plus k. And so the first thing I notice is that the a value is out front. So I'm going to try to do that. I'll take this 2, and I'll just factor it out of the first two terms because the k is out here anyway. So I might as well just not deal with this 14 right now. So I'll end up with this here. Okay, now here comes the interesting part. So what I want to do is I want to get this part here instead of this part here. So lots of ways of thinking about this, but what I want to do is I want to make this look like this for a second: x minus h times x minus h. And what you'll notice is that both of these are identical. Okay, right now we don't have anything like that over here. So what I'm going to do is I'm just going to draw a square. I'm going to think about it in terms of a square. And right now I've got x squared in here. So that I'm going to put in this square here. And where does that come from? Well, it comes from x times x. Then inside these boxes here, this one here and this one here, I'm going to try to put in this 6x. So I want it to be a square because I want both sides to be the same size like it is over here. So I'm going to split that up into minus 3x and minus 3x. Now I'm going to think about how I would, or what I would need to multiply to get the things in this box to be minus 3x. So I'd have to have a minus 3 here. So that x times minus 3 is minus 3x. And then the same thing down here. Okay, now, the only problem is I have this empty box here. So this has to complete my square. It has to finish it off. So I have this minus 3 here and this minus 3 here, and they're going to multiply to give me positive 9. So that would be what I would need to have in that square in order to complete it. But I can't just add on plus 9, so I'm going to subtract 9 there as well. Now I haven't done anything. I added 9 and I took 9 away. So I'm just going to put that back in my function in my algebraic representation. So I've got x squared minus 6x plus 9. I'm just going to switch to red again to show that that's the piece I needed to take off. And I still got the minus 14. Okay, we'll just keep going. Now we know this can come from multiplying this and that. So we're just going to replace it with that. So this becomes x minus 3 times x minus 3, but we'll just be lazy and we'll show it like that. We still have that minus 9 there, and that's like the most common mistake people make, is just forgetting about that. So make sure we don't do that. And then I'm just going to distribute the 2 back in. I'm going to end up with 2 times x minus 3 squared minus 18 minus 14, which will end up being 2 times x minus 3 all squared minus 32. Which means I have a vertex at 3 minus 32 on this one. So all we did was we just rearranged this thing, keeping in mind what we were trying to get, which is that. Okay, so that's one thing you can do in order to investigate the function, in order to get a sense of what it looks like. Another thing that might be useful is to find the x-intercepts. So let's try that too. So we'll stick with that same one. We still have f of x equals 2x squared minus 12x minus 14. And now we're going to look for the x-intercepts. So what are the x-intercepts? So a couple of options. Easiest thing to do, use anything that you've discovered in previous years. So if this is a, b, or c, we can find the x-intercepts with the quadratic formula. So we get minus b plus or minus the square root b squared minus 4ac all over 2a. And I mean, you can just plug these in, okay? Another option is you can factor. So you can use quadratic formula. Let's try factoring. Okay, so we'll say f of x is equal to, okay, let's common factor out the 2. So we get x squared minus 6x minus 7. And then we're going to factor this by looking for two numbers that multiply together to give us minus 7 and add together to give us minus 6. Well, that's just going to be minus 7 and 1. Okay, so we get 2x minus 7, x plus 1. So now we know that the x-intercepts are 7 or minus 1. Okay, so those are the two numbers that would make this 0, right? So 7 minus 7 is 0, and minus 1 plus 1 is also 0. So those are the two options you have. Okay, now I'm just going to review one other way you could have factored this. Okay, so let's just write this out. F of x equals 2x squared minus 12x minus 14. Now, suppose you didn't realize that you can common factor that. Well, you could instead use decomposition. So if we multiply these two numbers together, we're going to get minus 28. So let's look for two numbers that multiply together to give us minus 28 and add together to give us the minus 12. Okay, so that's a little bit harder because these numbers are just larger. So let's take that 28 and let's just write out things that you can use to get 28. So 1 times 28, 2 times 14. So actually, let's just stop there, because if you see one that'll probably work, let's go with it. Okay? So 2 and 14 can be used to make 12. So let's just make sure that we use the right signs. So we get f of x equals 2x squared. And I'm just going to write in the 14x and the 2x and the minus 14. But I want to make sure that I get minus 12. So I'm going to make it minus 14x and plus 2x. And then I'll keep going. Okay, so now I just have to factor by grouping. So here's my first group. Here's my second group. If you switch the 14x and the 2x, this is still going to work. So it won't matter which order you choose. So 2x is the common factor for the first group. And you get x minus 7. And 2 is the common factor for the other one, and you still get x minus 7. And that's what this is all about. You're making the correct choice of these two numbers here so that these end up being the same in the end. So now we just common factor out the thing that's the same in both terms. So you get x minus 7 from this one and x minus 7 from that one. And left over you get x minus 7 times 2x plus 2. And then to really finish this off properly, you should take out that, or you should take out the common factor from that. So that's going to be a 2. You get x minus 7 and x plus 1. And so you get your x-intercepts as 7 again, or minus 1. Now suppose that you didn't realize to do this step. Well, you could have just found the x-intercepts from there by letting f of x equals 0, because that's where the x-intercepts are. It's when you your output is 0. And so what numbers could make that 0? Well, from the first part, you can clearly see it's 7. So one of your x-intercepts is going to be 7. Or the other one, maybe you don't see it right away. So you say, okay, well, what will make this 0? So I set it equal to 0, and I check what the consequence of doing that is. So I just subtract 2 from both sides. So 2x has to be equal to -2. And then I divide both sides by 2. So x is going to have to be -1, which is exactly what we expect. So there's a variety of different algebraic sort of tips and tricks that you can use to play around with quadratics. Now, every type of function has its own. So we're going to explore those over the course of the year. These are some that you've seen already. So we'll just call these our tools for tinkering with quadratics.